Good afternoon. Welcome everybody to this joint ECA Group iXblue webinar to look at using unmanned systems in standoff MCM and in particular how to avoid obstacles. My name's David Cunningham. I'll be your host for today, but I'll introduce you to the contributors shortly. It's going to be about a 15-minute discussion, exchange, presentation, followed by questions. So please post your questions if you've got any on the webinar platform, and we'll do our very best to answer them at the end of the show. Moving on, introductions. I'd like to introduce Marc Pinto, who's joining us from Toulon on a live link. Marc is the scientific advisor for ECA Group. Welcome, Marc. And on the sofa here with me is Julien Guichard from iXblue. He's the sonar programs manager.
Hi, David. Hi, everyone.
So quickly, I think we'll move on and crack on with a quick description from you, Marc, if we can, just to set the scene of this this topic, which many people will be familiar with, but just for completeness, what's it all about?
It's about the standoff MCM system. That basically means a ship which remains out of the minefield with the crew safe and away from danger, and unmanned systems being sent into the minefield. These unmanned systems, what we call the tools. And you see quite a picture of the different type of tools in the toolbox we have here. Underwater tools, surface tools, aerial tools, and these tools all work together to do the MCM job, which was before done by human operators alone.
Okay, that's great. So it's about the Belgian-Dutch MCM program. Obviously, ECA bringing this unmanned toolbox to the solution. And Julien, perhaps you can just give us a very quick overview of what iXblue will bring to ECA's elements in this program.
So actually, iXblue is providing three main elements to this program. The first one is the fins compact INS, which will be directly integrated into the AUVs of ECA. The second one is the GAPS USBL system, which is providing positioning, underwater positioning. And here we are providing a new generation of GAPS system, and we will add to the positioning capacity, the communication capacity from surface to underwater systems. The third one is the FLS 150, so it's a forward-looking sonar, is here for the safety of the vessel, so it will be fitted in the USV, and then will provide all the information of the water column from the surface to the seabed.
Okay, and we'll dig a little bit more into that shortly. Coming back to you, Marc, just to get into a little bit more detail, perhaps you can just give some highlights of some of the challenges and so on that you've addressed in creating this toolbox.
Yes, we have a little video here which goes through what the typical operation of the system is. So when the ship arrives close to the minefield, then the tools are put in the water, and there's a complex launch and recovery from the ship, which is fully automatic, both the launch and the recovery. And here you see an AUV put on the USV, which are both deployed together. And subsequently, the AUV will be also automatically and perform a mine search. Here you see now the USV is put in the water, is leaving the ship. And there it's gone. And now the mine search will begin with the underwater systems. The UV is going underwater. Here the USV is also equipped with the sonar, which in the actual system will be the FLS 150 mounted on the USV. And the USV can also act as a communication relay. The underwater assets come to the surface at proximity to the USV. The data is downloaded, and points of interest, which are automatically detected, are fed into another USV, which is equipped with an identification system we call the C-scan. So here you see the C-scan, which is a remotely operated vehicle equipped with a video camera and high-resolution sonar. This system is put in the water and approaches a mine-like contact, and here's a positive identification of a moored contact mine, as you can see. And following that, the next stage, which is not shown, is the destruction of the mine.
That's excellent, Marc. It's obviously a highly complex system of systems, and in this brief forum, we don't have too much time to go into too much detail. But you mentioned the FLS 150, and it will be fitted, as I understand, on the USV. Could you just describe the role of it on that platform?
Yes, one of the main objectives of this sonar is for us to detect objects in the water column, and in particular, all types of obstacles which can be inserted by the opponent forces, in addition to mines, to hinder the safe operations of the unmanned systems. You can think as fishing nets as a good example of a pretty dangerous threat, which is difficult to counter with AUVs alone. So the idea is to have a cooperative network of unmanned systems with sonar on the USV, which benefits from its position high in the water column to scan the whole surface of the water and feed this information in a timely fashion to the AUV. And obstacles can be removed actually or avoided or removed depending on the scenario.
Okay, so I understand. So it's essentially it's going to allow the system to perform a sort of a pre-survey of an area before deploying towed or unmanned assets into the water column. Yeah.
Yes, exactly.
So Julien, maybe moving to you then, focusing now more on the FLS 150, and perhaps you can give us a quick overview of the product, the technology, where it's come from.
Yeah,
and where we are with it.
Actually, iXblue Sonar is doing sonar system for more than 10 years now, and mainly for civilian application. Based on this civilian knowledge and hardware and software for the sonar, we are building now a new generation of sonar for military application and avoidance application. We call that the FLS series, and the FLS series is made of two different products. The first one is a FLS 150, so for the one that will be fitted into USV of ECA on this particular program. And this one is really dedicated for light or unmanned vessel. We have a range of detection between 300 and 400 meters, depending on the object you want to detect. And the second one is a much bigger system, FLS 60, working at 60 kilohertz. And this one have a very high range, between 600 and 800 meters, again, depending on the object you want to detect, and is more dedicated for the first rank vessels or submarine applications. Mm-hmm. Inside both of these products, we are bringing a complete from surface to seabed detection to make sure we monitor all the water column, including the seabed itself. The performance of the sonar is really depending also of the environment. So to take care of that in real time, we embed inside the sonar itself a tool to be able to evaluate the level of performance of detection we have in real time in front of the vessel to make sure we have no risky zone that should be seen by the sonar but is actually blind due to the environment. Then we also provide a complete automatic tracking and pre-classification of the target to make sure the target we are tracking and detecting is a risk or not a risk for the vessel and for the crew. The main goal is the security of the crew and the vessel. And finally, we also have a system which is completely cyber secured, so ready to be fitted in a complex military environment with different vessels, for instance.
Mm-hmm. Okay, I understand. Okay, well, that's great. So, well, that's the end of our sort of exchange on the topic. I think clearly, if there's any questions after the event, people can get in touch with either of the partners here, ECA or iXblue. We've got time for some questions, and I think we've got some appearing on the screen in front of me here. So, if I read them out, and I can either direct them to you, Julien, or to you, Mark. We've got a first question. It could be for you, Mark, this one. How do you intend to remove the obstacles once detected?
Yes, our objective there to remove the obstacles is basically we do have a clearance diving team on board the vessel, and so in specific occasions we do deploy them inside the minefield for tasks which are difficult to automate or foresee in advance. So this is a prime way we have with dealing with moving the threat.
So a sort of a conventional approach. And then so there's another sort of associated question, which you've touched on already, but what is the precise nature of the obstacles you expect in the water column?
Well, one we can think of, which is very common, is fishing nets. So these are nets which are deployed in the water column and usually held with buoyancy systems so that they basically stay upright. They are very difficult to detect from an AUV because the AUV has a very limited forward-looking sonar. So the other type of obstacles is cables, which can be put in the water column between two poles and which can easily cut any kind of fiber optic or tow cable of a towfish, for instance. Very dangerous obstacle.
Yeah, okay. We've got one here for you, Julien, now, which is about export control of the FLS series. Can you say a word about that?
Yeah, sure. Actually, we have to make the difference between two different products, FLS 150 and FLS 60. The FLS 150 is completely export-free, and the FLS 60 with higher grade of performance is limited to export control.
Okay.
So that will depend of the final user of the system.
Okay. If you want to know more about that, please contact us after the event and we can add a bit more detail to that. Another one about the FLS performance, thinking about speed. What's the speed limit for the FLS?
So actually, we have no speed limitation in terms of sonar itself. The main limitation we may have is due to the environment, the vibration, or the noise. It could be the noise of the platform at a very high speed. Mm-hmm. But on the sonar detection wise, we are very able to be working at a very high speed. As soon as the platform is able to provide a very low noise environment and low vibration environments. Okay.
We're waiting for more questions, but in the meantime, we've got one here, which is, well, somebody takes the message that the sonar has been developed from a fisheries sonar. How can it be trusted for critical naval application?
Yeah, when we speak about fisheries sonar, it's very high grade fisheries sonar. We have to know that fisheries and fishermen, they are using a lot of different sonars, and they need to have a very trustable sonar, because when they go at sea for a very short period of time. They need to ensure they need to be able to operate the sonar. So coming from the fishery industry, actually, we have a very reliable sonar in terms of reliability on the field. And then we also have some level of performance to reach if we want to provide the proper data to the fishermen. So coming from this market, which is actually a quite demanding market, we already have a strong base. And obviously, for the level of qualification, which is much higher in the military market, we are upgrading the hardware we had and the software we had to bring the product dedicated for the military market.
Sure. Yeah, which is something that iXblue,
and we are used to do that in iXblue, indeed.
Yeah. We've got one here now for you, Mark. I think it's more sort of a program level question. When does the MCM program, when is it due to be delivered? And are there any other navies interested in the solution?
The program itself covers a span of 10 years to deliver the entire fleet. Actually, the first prototype systems will begin to be delivered in 2022 for operational test and evaluation. And actually, some components have already been delivered to the Dutch Navy. So it's a phased kind of delivery program.
Okay, I think we are expecting another question, but it's finding its way through the platform here. Give me a nod if that's the case, or otherwise no. Okay, no, I think that's it. We're not going to wait. We're not going to sit and wait for questions, are we? No, we're not. Okay. That's the end of the questions. So I think just a quick wrap up. I'll say, well, thanks to Mark and to Julien. Maybe you'd like to say a final word and a goodbye from you, Mark.
Thanks for everyone for joining in, and I hope to see you in real life somewhere.
Thanks. Good to see you. We'll see you again soon. And Julien, thanks very much for being here today. And
thanks. Thank you. It was a pleasure.
Yeah. I think thank you very much for joining this combined ECA iXblue webinar. I hope we've intrigued you, answered some questions. And if you want to follow up with either of the partners here after the event, you'll be more than welcome, I'm sure. Thank you very much. Goodbye.
Thank you. Goodbye.